Hello my dear, I welcome you again in the series of Score Booster. So this is the series of Score Booster of the subject of Production and Material Science, and in this series we will the subject will part in two parts. The subject will be divided in two parts. First, part 1, part 2. So some problem we will discuss in the part 1, and other problem which is left, which is tomorrow. Tomorrow we will all take a class of take a series of part 2. In that one, there also a problem we will include. Okay, so so my dear, this is the Score Booster. So the main orientation of this session is based on the numerical portion. Basis on the numerical portion. So we will cover only the numerical, and it is not only the numerical. We will also discuss some background related to that numerical. Why? Because let's suppose the same concept problem, it will appear in the GATE examination, so you can able to solve that question. Okay, so we'll also discuss some related to the concept, little bit concept, not much more, very little bit, so that you are so that you can digest the concept. That means a solution also tomorrow, and material science will discuss tomorrow. So 1, 2, 3. Generally 3 and 4 portion will discuss tomorrow. Remaining casting, metal forming, non-traditional, welding will discuss today's. Okay, so we'll discuss today's lecture. Okay, thank you, Thiru, thank you. So so my dear, so let's start with the today's first problem. Read the question first and try to solve it. Okay, who is watching this video in the live or in a recording? Why? Because this video is available in YouTube, IMS YouTube channel, so it will be available. So who's watching this later on, जो आज इस वीडियो को देखेंगे, तो आप हर एक क्वेश्चन को पॉज करके, कुछ टाइम तक पॉज करके आपको उस क्वेश्चन को सॉल्व करना है, तब आप उसको सॉल्यूशन पार्ट को देखना है. ऐसा नहीं कि बस वेट कर रहे हैं, लेक्चर को स्टार्ट कर दिए सुनना. नो. So this is the first question. I will read the question. I will give you timer also 1 minute. First I will read the question, then I will give the times for 1 minute, so that you can think the question what they are asking, and then I will solve this question. These are the 3-step question, 3-step process. First, reading the question, I will give you time, then I will solve. Okay. So what is the question? First, read the question. 2 7 mm thick sheet plate are placed 5 mm apart and welded by a butt joint, right? The joint is butt. Welding is carried out at 20 volts. Heat transfer efficiency, it is given 80%. Melting efficiency, it is given 60%. If the heat required to melt the steel is 12 joule per mm cube, that means this is a per volumetric basis, and heat required to melt the sheet. So heat required to melt the sheet, it is given 12 joule per mm cube, and also heat required to melt the sheet per second. So this is your joule per second. That means what it is given here in the form of unit melting efficiency. That means unit melting it is given. That means it is a per unit volume basis, and it is a per unit time basis. So this is your joule per mm cube, and this is joule per second. That means what? Both value it is given. Okay. Then the welding current is, that means we have to find the current. What is the current of this welding process? What is the current? Okay. So let's start. I will give you a timer for 1 minute, so that you can very well understood the problem. Okay. Let's start timer for 1 minute. Okay. Just start. Just start with a Hi Mathan. Hi. How are you, beta? Fine. Good evening, beta. Good evening. So this is the first question. Okay. Now time is up. We'll discuss this thing. This is the production. Okay. So this is the welding question. First welding question is there. They are supposed to find the current. Okay, beta. Understand the concept. Okay. So what is given here? Given. One second, my dear. 1 second, just 1 second. It will delete, no problem. Okay. So what is given? We'll increase the pen size also. Okay. What is given? Given thickness of the plate. Thickness of the plate, it is given 7 mm. Thickness of the plate, it is given 7 mm. Okay. Now, distance between the plate, D it is given. Distance between the plate, it is given 5 mm. Voltage, V is equal to 20 volt. Okay. Transfer efficiency, it is given. Heat transfer efficiency. Heat transfer efficiency, it is given 80%. Okay. Melting efficiency, it is given 60%. Melting efficiency. Heat required to melt. Heat required to melt per unit mmq, volumetric basis. So heat required for melt, it is denoted by UM. That is your 12 joule per mmq. Again it is given heat required per second. So that means heat required per second for melting per second for melting, it is given 2100 joule, it is given. Okay. Let's suppose V is the welding speed. V is the welding speed. I is the current supply during time T. Time, let's suppose T. During time T, what is the current supply? I. Okay. Okay, my dear. So let's see this thing. What is the melting efficiency in this question and unit melting efficiency? So let's suppose this is our plate. Just think. This is a plate, it is given. This distance apart, this two plate, it is given. Okay, this two plate, it is given. This two plate, it is given, my dear. Okay, this is the plate, it is given. And here the welding will take place. Here the welding will take place in this. Okay, this gap, this thickness, it is given T. This T, it is given 7 mm. Okay, the gap, this gap, it is given. This gap, it is given 5 mm. 5 mm. Okay, voltage, it is given. Now, so for the welding of this material, this arrangement, this is a butt joint. Yes, this is your butt joint. Okay. Now, so what you have to do? There is a power source. Yes or not? This power source have a power which is V into I, and this V into I is equal to I square R into time. This is the available power. This is the available power in the transformer. This is the power available. Now this power will be, that means this energy will be transferred to this weld. Okay. So what is the power available? that will be lost due to the transmission. There is a lots of things in there, wire, all the things is there. So some power will lose during this power law. What is the power available and what is the power which is giving? Both have a different value. So there must be a transmission loss. So to account for the loss, we consider there is a transmission loss. Now my dear, if this, after this efficiency will consider, that is the power available for welding. Power available for welding. So if you multiply V into I into eta T, that is the power available for the welding. But during the welding, my dear, during the welding, some part of the heat will lose to the surrounding and some part heat will lose by the some part heat will lose, energy will lose in the surrounding and some part to the base metal, that is, and the some part which is loose in the base metal, that will be responsible for heat affected zone. Heat affected zone. So let's suppose some this we'll change the color first. Let's suppose, my dear, let's suppose some part of heat will utilize to the weld, that means heat utilization. Some part heat will be given to the base and some part heat will be lost to the surrounding. So heat energy loss, this is also energy loss, and this is your heat utilize in this one. This is your heat utilize, okay? This is your heat utilize. So some part what is the power available, that will be some part will lose. Why? Because there is a many components there, so there is a transmission efficiency. So that for that sake of this one it is given. Now part of the some heat which is utilized to weld, some part will lose to the surrounding and some part will lose to the base metal. So what is the actual heat will use, that will account for the melting efficiency. That will account for the melting efficiency. So what is the net heat which is available, that is Vi into transmission efficiency into melting efficiency. Okay, we'll discuss this thing. That means what is the available energy, the available heat which is required to melt this material. So heat required to weld. My dear, this heat required to weld, it is not this much. The heat required of the weld, which is account for the transmission efficiency and mechanical efficiency. So heat required to weld, it is nothing. What is the power source? V into I into transmission efficiency. Some part is loose and some part it is your mechanical efficiency. Some part it is mechanical efficiency. So this is the heat required. Heat required. This is the heat required. This is the heat required. Okay. This is the heat required. Okay, beta. This is the heat required. Now, so this is the heat required to weld this, to melt the material. That is the net heat required. Now, my dear, now see this one. What they are asking? They are asking that what is the current? Then what is the current is that? So this thing is clear. Now, my dear, see. So now how to adjust? This is very important. So this is the heat required. That means this is the energy, and this energy, it is what beta? Watt voltage into current. That means this unit is always joule per second. Joule per second. And this is also, you can treat it as like that. This is equal to, you can take like that. What is the area of the weld? Let's suppose this is the area of the weld. Area of the weld. So this is the area of the weld. And this area of the weld, obviously it is your square into my dear, this is joule per second. We have to find joule per second. So this is your unit melting energy, and this is your joule per cube. Now my dear, this square and this cube, 2 will cancel. So joule per right? This is joule per but we have to require joule per second. So multiply with weld velocity. Velocity of weld. And this velocity of weld is what? Per second. So my dear, this square, this and this will cancel. So final unit is joule per second. So see my dear, you can equate these two, and these are the simply balance, unit balance, simply unit balance. So balance this unit and find any of this. Okay. Now come to the question. This is correct. Now come to the question point. What is that? It is given heat required per second, it is given. This value joule per second it is given. How much? This value. See, this is given. Joule per second it is given. And this joule per second is what? This one. Simply. This is given. So this one. So we can write like that. So what they are asking, there are two things. Oh, in this one, we can, it is in the question it is not necessary, but here we can also find the velocity of weld easily from this relation. From this relation, why? Because heat required it is given, 21 joule, area of the weld given, given, automatically you can find weld velocity. Hi Vani, hi, hello. So from this relation you can find, from this relation you can easily find the weld speed, but in this question it is not required. Okay, let's suppose we find the weld speed by interest. By my interest, we have to find weld speed. Weld speed. So weld speed we have to find. So what is that? V into I, transmission efficiency, mechanical efficiency into area of the weld into unit melting energy into velocity of weld. Okay. So current, we don't have a current value. We don't have a current value. Yes, current they are asking. So we don't have a current value. Okay. We don't have a current value. So I is I. Now transmission efficiency it is given. How much? 0.8. Melting efficiency it is given. How much? 0.6. And now my dear, the area. What is the area of the weld? This is a gap. So this is the area of the weld. It is like a rectangle. So 0.7 into 0.5. 7 into 7 into 5. 7 into 5. What is the unit melting? This is your joule, 12. This is 12 na? Yes, 12 joule per meter cube. 12 joule per meter cube. So this is your 12 joule into velocity of weld. Now check the unit. Now check the unit. This unit it is in joule per second. This unit it is in, this one it is your square. This 12 it is your joule per cube. This weld speed is per second. Check the unit. This cube, this will cancel. So see, joule per second is correct. Okay. Now from here we can find easily. Now I it is not given here. Here I it is not given. So yes, this is the one format. So this is the in this format that we have to find the relation between I and weld speed. Okay. So this is one. Now it is not asking the question, but by interest I will just ask. Now we can equate this to, why? Because we have to find the current. So we can equate this one by heat required. So this is joule per second, and this is also given joule per second. Yes, it is given. It is given. See, heat required, joule per second, it is given. So heat required, calculate current I. Calculating the current I. Now my dear, see, what is that? It is given. Heat required per second, it is given 2100 joule per second, it is given, and that is equal to, you can write like that, area of weld, unit melting efficiency into velocity of weld. Now 2100 area of weld 5 into 7, unique melting energy 12, and this is the weld speed, velocity of weld. So easily we have to find velocity of weld, no problem. And this velocity of weld, it is 5 mm per second. 5 mm per second. If their question, they are asking two questions, 5 mm per second. So it is not asking this question, but we can take like that. Now, but they are asking current. They are asking current. So current you can easily find, equate this value is equal to VI into melting efficiency. Now 2100 joule per second, that is equal to VI is given power into efficiency, melting efficiency, transmission efficiency. Yes, V given. So from here 2100, V given 20 volt na, V given 20 volt, current I it is given, melting efficiency 0.8, transmission efficiency 0.6, let's suppose it is given. So from here you can easily find current I. From current I you can find, and that is your 218.75 ampere. That's it. So current and welding speed you can easily find. Clear na? Clear? Everyone please tell me, this is clear na? So these are the concepts. How to, only dimension, and this is okay, VI eta T into AW. So if you know this relation, one question is always present, will always present in the GATE exam. Okay, एक क्वेश्चन आपके गेट पेपर में इस तरह के रहेंगे, so इसको समझ लेना. Okay, done. Now, so this is the question number first. Before going to the next question, I have one update for you which is useful. What is that? Please see. There is a benchmark yourself against the best what is that? Test series plus. This is not only test series, this is a test series plus. Plus that means we have something extra. What is that? 130 ऑनलाइन टेस्ट सीरीज. यस, आपको 130 ऑनलाइन टेस्ट सीरीज अवेलेबल होगा. उसके बाद along with that 33-year GATE PYQ books. In book there are two types of book. One is the technical subject like your mechanical, civil, electrical. Second one is your common for all math and general aptitude. So you got two books. One is technical subject, other one is mathematics and general aptitude. Next, you also आपके पास access रहेगा doubt solving portals का. So if you are unable to solve any problem, you can click that photo and post on the LMS portal. The faculty, concerned subject faculty, will reply within 24 hours with best solution. Also, online revision and score booster, that means the series that like that, online revision, score booster like that, that also you have. Post GATE guidance also, and also there is a mock test interview, that means a rehearsal for the interview, main interview for PSUs and Master of Science. Now second one is that if any student, अगर आप live online program join करते हैं, that means if you want to join live online program, so what the आपको क्या क्या बेनिफिट्स मिलेंगे उसके बारे में देखिए. 800+ आवर ऑफ लाइव क्लासेस विथ लाइव इंटरेक्शन. ओके, आपके पास कितना, हाउ मच, 800 आवर, उससे ज्यादा ही, कम नहीं, आवर ऑफ लाइव क्लासेस विथ लाइव इंटरेक्शन. Along with that, you got theory book, that all the basic concept, all the concept related to the GATE syllabus, ये theory book में available है. Exercise book, in the exercise book there are 3 level, level 1, level 2, level 3. Level 1 is basically the common question in UPSC, like the very basic question, UPSC, ISRO, SSC, JIN type का level 1. Level 2 pure on the GATE inclination, and level 3 it will little bit advanced, it is little bit conventional type of things. So this exercise book will cover all the range from 0 to infinite level, 0 to maximum level. ये exercise book आपको cover करेगा. उसके बाद ये not 34, this is 33. उसके बाद अगेन 33 गेट क्वेश्चंस बैंक्स मिलेंगे जिसमें आपका बस वीडियो सॉल्यूशन होगा. दिस इज वेरी यूनिक फीचर्स. अगर आपके पास कोई प्रॉब्लम है किसी क्वेश्चंस में और उसको देख के या रीड करके यू आर नॉट एबल टू अंडरस्टैंड, सो इन उसके बगल में एक क्यूआर कोड, उसको दैट बिसाइड देयर इज ए क्यूआर कोड, सो स्कैन द क्यूआर कोड, ऑटोमेटिकली द वीडियो विल प्ले एंड यू कैन वॉच द वीडियो एंड यू कैन देन आपको बहुत ही कंफर्टेबल महसूस होगा जब आप इस वीडियो को वॉच करेंगे, क्योंकि उसमें डिटेल्ड एक्सप्लेनेशन है. ओके, उसके बाद आपको 12 personalized one-to-one mentorship programs, 12 one-to-one mentorship programs. That means अगर आप you are hesitating in the class to ask anything, you can book a my plan session. We are interact with one-to-one. That means आप और मैं ही रहेंगे, बीच में कोई नहीं रहेगा, तो आप easily कुछ भी पूछ सकते हैं, कोई भी कॉन्सेप्ट, किसी भी चीज के बारे में आप पूछ सकते हैं कंसर्न फैकल्टी से. उसके बाद 130+ ऑनलाइन टेस्ट सीरीज विथ होगा, 130 ऑनलाइन टेस्ट सीरीज. along with that you got a video solution for that all the test series paper. okay, so अगर आप चाहते हैं कि काउंसलिंग, आप चाहते हैं कि इस चीज के बारे में जाने या ज्वाइन करें, तो आप इस लिंक पे क्लिक कीजिए या आप इस नंबर पे कॉल करेंगे. इफ यू कॉल दिस नंबर दे कैन आप उसको सामने वाला जिसको आप कॉल करेंगे वो आपको बेटर अंडरस्टैंडिंग देगा. ओके, सो वंस आपको जो इंफॉर्मेशन दिया एक बार करो आप. ओके, नाउ नेक्स्ट सेकेंड प्रॉब्लम, जस्ट रीड दिस क्वेश्चन बेटा. A resistance seam welding operating a resistance seam welding operation is performed. A resistance seam welding operation is performed on 2 pieces of 5 mm thick aluminum sheets. Okay, the specific melting energy, yes, see again it is given, that means this is UM. A specific melting energy for aluminum, it is 2.9 joule per mmq. The process parameter, what is the process in this welding involves, it is given. Current it is given, and welding duration, that means welding time, it is given. Resistance, that means if you join two plate and you want to weld in the seam welding, so there must be a resistance between that two plate, must be a gap, very minimum gap, but that resistance will provide the resistance, and that is 75 micro ohm. The electrode wheels, and we feed the electrode, and that electrode is लपेटा रहता है, एक व्हील रहते हैं, उसके ऊपर ऐसे ऐसे राउंड रहता है इलेक्ट्रोड व्हील. जो इलेक्ट्रोड रहते हैं, उस इलेक्ट्रोड का डायमीटर 6 mm in diameter, and the electrode will have a diameter, what is the rotating wheel, that is have a diameter 250 mm. The individual, and we have to form a nugget. Why? Because this is resistance welding. Resistance welding, there is a formation of nugget formed, and the nugget dimension it is given, it is in a cylindrical shape, 6 mm diameter and 3 mm thick, 6 mm diameter and 300 thick. It is like a cylindrical, a disc you can say, it is like a disc, है ना. Now assume that weld nugget in a cylindrical shape, it is given cylindrical shape, no problem, and are continuous to form a seam. The power unit derives the process. What is the power unit? Derive the process requires an off time between the spots is 1 second. That means you are doing the welding, create one spot. Now you creating the next spot, there is a delayed. So total time, what the total time is required? 0.3 plus 1. 1.3 is the total time required to weld, to start the next welding. That means duration of time taken of the welding is 1.3 second it will take, and to the next welding it is 1.3 second. Okay. The fraction of energy generated to goes into the formation of each weld nugget, and the fraction of energy given to the nugget, that means energy utilized. Okay. Second, rotational speed of the electrode wheel. What is the rotational speed of the electrode wheel? Okay. So let's start. I will give again a timer. Let's suppose I will give you time, no problem, for 1 minute. Just start with a time's up. Okay, let's start. So see, there is a weld. To do the welding process, let's suppose this is one plate, there is another plate, and here we form a nugget, cylindrical nugget. So this is your nugget. Okay. Now for that one we have to provide a electrode. Electrode is providing. Here it is given. The specific melting and all the things it is given. The individual weld nugget is formed. Nugget. Individual nugget. This is nuggets. This is nugget will form, and 6 mm diameter and 3 mm thick. So thickness of this nugget it is given. This nugget it is given 3 mm, and this diameter it is your 6 mm. This is nugget it is given. Okay. Diameter. Assume that the welding nugget is a cylindrical shape. Okay, and continuous to form a form. The power unit is derive a process required to off time between 1 second. The fraction of energy generated to goes to the interface to each welding of the nugget, and the rotational speed of the electrode wheel is. So there is a electrode wheel. This, let's suppose this is your shaft. On this shaft, let's suppose this is your wire is mounted. This wire is mounted. This wire is mounted, and it will be like that. There is a electrode it will be feed. So this wheel it is given, and this diameter it is given, wheel diameter it is given, how much? Wheel diameter it is given, duration interface, the electrode wheels have a diameter 250, this diameter is 250 mm, wheel diameter it is given, okay, wheel diameter it is given, all the things is given, and yes, and thickness of the plate it is given or not? A weld itna, interface itna, the electrode wheels itna, individual nugget form itna, okay, and the thickness it is given, I think. Question bhi bahut bada hai na. Thickness it is your 5 mm. What is that? 5 mm. So this plate thickness it is your 5 mm. 5 mm. So it is not like that. Actually, this nugget it is in the form of this one. Beta. See, it is not like that. Sir, you can see that sir, this thickness is 6 and the total thickness is 5. How it? So nugget it is like that. There is a nugget. This is a nugget. This will be tried to bend like that, and this is the thickness. This thickness, plate thickness. This is your plate thickness, my dear. So this plate thickness it is given. This plate thickness it is given total, na? So it is given 10 mm. Total plate, and total nugget it is your 3 mm. Like that. Clear, na? There is 2 plate. Like that. It is given like that. Okay. Why? Because during the resistance welding we have to we are doing the हमें क्या करना पड़ेगा, इसको प्रेशराइज करने पड़ते हैं, दबाना पड़ता है. दबाने से क्या होगा, मटेरियल थोड़ा सा अंदर की ओर आ जाएगा. Clear? So it is given, time duration given, and interface resistance it is given. Resistance it is given total 75 micro ohm. Okay, diameter it is given, diameter of the wheel. Okay, my dear. So now, my dear, heat required to melt of this volume. How much the heat required? To the how much heat supplied? How much heat required to the how much heat supply? That means heat required to melt of required volume. Required volume. Let's suppose we are doing HM is equal to what, beta? Unit melting efficiency UM, and what is the unit? Joule per mm cube into, we don't want mm cube. We don't want mm cube. So only we want a joule. So we multiply with the volume, and this volume of nugget. This volume of nugget. So this is heat required to melt this nugget. Heat required to melt this nugget. So what is UM? It is given. How much it is given, beta? UM 2.9. Yes, 2.9. So this is 2.9 into volume of this nugget. This cylindrical volume of this nugget is what? Pi by 4 d square into this height of the nugget. This is the height of the nugget. H diameter of the nugget, height of the nugget. This is the volume of the nugget. This is the volume of the nugget. So pi by 4, diameter it is your 6 square, height of the nugget it is 3. So if you multiply this, come to this is your 245.978 joule. This is the heat required for one nugget. This is the heat required for one nugget. Okay. Now, how much heat will be generated? This is the heat required, but how much the heat will be generated? That means energy will generate due to the power source. Okay, from the power source. So, how much the heat will supply from here? Heat supply. This is heat required from here. Heat supply. Heat supply. And heat supply from where? From where? Power source. From power source. And power source is what beta? I R square into time. I square into T. Okay. Now, what is the power source? So, heat supply. So, I it is there. So, heat supply. I square R into how much time it will take. So, I it is given beta. How much I it is given? Current. Current it is given. 6,000. 6,000 square, and resistance it is given 75 micro ohm. So, 75 cross 10 to the power minus 3 and ohm microns minus 6, not minus 3, minus 6 into how much time it will take for this one weld. This is 0.3. How much time it will take? 0.3. So, this is 0.3. So, if you calculate this thing, this is 8100. So, this is heat supply and this is heat required. So, obviously, heat supply is more. Heat supply is more. You are supplying 810 joule heat, but the weld only consume, but during the welding, the actual heat will consumed 245. Remaining will be lost. Remaining will be lost to the base metal and plus to the surrounding. Remaining will be lost. So, you can easily find the loss. What is the loss? This total minus this one is the heat loss. Okay. Now, my dear, so how much fraction of heat will be going to the weld nugget? They are asking that. See, the fraction of energy generated that goes into the formation of one nugget. Fraction of heat generated. So, this is your fraction of, what is that? Fraction of energy generated that goes into the formation of each nugget. So, how much the energy generated? How much the energy generated? This is the energy generated. And this is energy going. That means this energy for formation of one nugget. And this is your heat generation. Heat generated by the power source. By the power source. So, how much the fraction generation is equal to this one 245. That means heat required for melting divided by heat generation into, okay, how much fraction? So, melting it is how much? 245.978 divided by 810. So, this is how much beta? It is approximately 0.3. 0.3. So, 0.3, yeah, 30% is only What is the meaning of this thing? That means only 30%. That means only 30% energy will utilize to form one nugget. Clear na? To form one nugget. But this is the first. And second one, they are asking that for the second one, this is important. The rotational speed of the electrode wheel. The rotational speed of the electrode wheel. How to calculate, beta? So, what is this peripheral speed? So, let's suppose this is your wheel. This is your wheel. Let's suppose this is your wheel. And electrode are feeding like that. This is the radius of the wheel, your diameter. So, what is the peripheral speed? What is the peripheral speed? Please tell me. This is your electrode wheel. This is what? Electrode wheel. So, this is your electrode wheel. That is a wheel. Wheel is there. Now, so this is your feed. You are feeding. Okay. Now, so peripheral speed of electrode wheel peripheral speed of electrode, we are finding this speed in. So peripheral speed of electrode wheel is what? What is the dia of nugget? See, my dear, there is a very important information. This dia of nugget, electrode feed, this dia is your 6 mm divided by total time. That means time for welding plus idle time. So 6, and this is your second. So 6 divided by 1 plus 0.3 second. That is your mm per second. Mm per second. Now, my dear, there is a one confusion in the question, student community. Why we are taking 6? Why we are not taking this height? So 6 is your nugget, which is your electrode diameter. This is a type of electrode. This is your electrode. So this is your electrode dia. So what is the electrode dia? That we will be selecting for the calculating of electrode wheel. Okay, so 6 divided by 1 plus total time. 0.3 it is during the welding, and 1 will shift from one nugget to other nugget. So this is how much? This is very important, I am telling you. So how much it is? It will be 6 divided by 1.3 mm per second. So this is our peripheral speed. Now, my dear, this speed is what? Pi d n upon 60, and that is your 6 by 1.3. So pi is pi, d is the, we have to find diameter of the wheel, dia of wheel we have to find, na? What do you find? And the rotational speed, no. Rotational speed. So this dia of wheel it is given. This is given, beta. How much? Dia of wheel, see? 5 meter. See, 250. Wheel have a diameter 250 mm. Wheel diameter it is given 250. That means this is D. D. So D is a 250. 250 N RPM divided by 60, that is equal to 6 divided by 1.3. From here you can find easily N. Please, what is the value of N? N, it is your 0.35. 0.35 RPM. So this is the rotational speed of the wheel, N. This is N. Clear? 0.35. Clear? So this is your 0.35 and 0.3. So 0.35 and 0.3. That means option number A is correct. So these are the very good question. Okay. Please put a star mark. Okay, there are 2 questions in there. Clear? This thing is clear? Now, we'll go to the next problem. So in this question it is there. So same concept is there. Same concept. Only the difference is there. So please mind it. This is important. Okay. Now next. Take this one. This is related to the casting, I think. Yes. Okay. So a cube, a sphere and cylinder. And the cylinder is H is equal to D. Ratio, height and diameter is same. Made of cast iron having same volume. All these have a same volume. Cube, sphere and cylinder have a same volume. Were casted under the identical condition. All the conditions are same. That means K value. If you apply the time for solidification, T is equal to volume by surface area. Directly time for solidification is directly proportional to volume by surface area. And if you remove the direct proportional, there is a K. So K is same for all the things. That is the concept. If the solidification time for cube, sphere and cylinder, it is denoted by TC, TS, T cylinder respectively, then what is the ratio? What is the ratio of the solidification time? Okay. What is the ratio? So I will give again your time. Just start with the time's up. Okay. So there is a cube. Oh, 1 second. So there is a cube. This is cube. Let's suppose this cube height all side A. Then there is a sphere of, let's suppose, diameter D. Okay, diameter of a sphere. And there is a cylinder, casting part, cylinder. And this is a dia of cylinder. And this is the height of the cylinder, and it is given D is equal to H. It is given, okay, for simplicity. Now, so this is cube, sphere, cylinder. Okay, cube, sphere and cylinder. Now, what is the time to solidification? Time for solidification, K is constant, volume of the casting, surface area of the casting, whole square. Okay, and this K is same for all the things. This is same for all casting, all type of cast, all same for all casted product. Casted product. Why? Because same condition it is there, and also their same material it is. So K is same. So T directly proportional volume by surface area square. Okay, we'll use this thing. Then find the time of solidification of the ratio. Okay, so first we have to calculate V by surface area. V by surface area also called module. What is called? Module. Modulus method. Modulus. So volume is what? AQ. Surface area is 6 surface, 6 into A square. So this is what beta? A by 6. This is for a sphere, cube. Now for a sphere, if you find V by surface area, this is exactly equal to D of a sphere by 6. Okay. Now if cylinder, volume by surface area, volume is what? Pi by 4 D square into H divided by 2 curved surface, 2 into pi by 4 D square, this curved surface, in plus this curved surface. So pi D into H, pi D into H. So if you put D is equal to H all the things, the value this value it is your D by 6. D by 6. Okay. This is D sphere of 6. This is D of cylinder of 6. Now it is given my dear, volume of cube, volume of this sphere and volume of cylinder are same. Yes or no? And that is equal to, let's suppose volume of cube is how much? AQ. Volume of a sphere is how much? 4 by 3 pi r of a sphere ka cube. Volume of cylinder is how much? Pi by 4 dq, you can say that. Pi by 4 dq. Volume is what? Pi by 4. Volume is what? Pi by 4 d square h. H is equal to d. So dq. So these are the, it is given in the question. In the question it is given, my dear. In the question it is given. Now from here we can easily find what is the value of this A in this, from this two relation. So A is equal to 4 pi by 3 power 1 by 3 into r of a sphere. Yes or not? R of a sphere. Now again from this two relation we have to find the diameter of the cylinder. So this D is equal to 16 by 3 with power 1 by 3 r of a sphere. So A we have to find in the form of radius of a sphere, D we have to find in the form of radius of a sphere. Simple then. Then we have easily take the ratio. So first we have to take time for solidification of the cube divided by time of solidification of the sphere. Then for a sphere, cylinder. So cube, and don't forget it is a square, my dear. Don't forget it is a square. Many students get mistake here. So time solidification for the cube is what? Volume by surface area of the cube divided by volume by surface area of the sphere. Okay. Now, volume by surface area of the cube is what? Volume by surface area of the cube is what? Volume by surface area of the cube is what? A by 6. A by 6, and A is equal to this one. Yes or not? So 4 pi by 3 power 1 by 3 RS by 6. That means 4 pi by 3 power 1 by 3 RS divided by 6. Now, this is for sphere. So, for a sphere, this is your ds by 6. So, ds by 6 we can write it is as r के term में. So, this is your r by 3. If you put r term, so r of a sphere divided by 3. So, r of a sphere divided by 3. Yes or not? So, r sphere divided by 3, correct? So, here r sphere divided by 3, the whole square, correct na? Now, this 3 and this is a 2, yes? So, this is your 2 RS by, so if you solve, this is your 4 pi by 3 1 by 3 RS divided by 2 of RS per power square. Now, this RS, this RS. Now, if you resolve, this is your 0.65. Clear? This is your 0.65. Now, this is your first. Second, time for solidification of sphere divided by time for solidification of cylinder. Again, a square. Now, for the cylinder, a sphere, see, cylinder and a sphere. So, for the sphere, RS by 3, RS by 3. For cylinder, so this is ds by 6 and this is d by 6. 6 is cancelled, that means ds by d. Yes or not? Sphere diameter by cylinder diameter, correct? Now, what is the sphere diameter? 2 into radius of a sphere. And what is this diameter? D of the cylinder, 16 by 3 power 1 by 3 RS. 16 by 3 power 1 by 3 RS power square. Now, again this RS, that RS cancel. If you solve this one, this is 1 divided by 0.76. This is 1 divided by 0.76. Now, if you take the ratio, T of cube ratio, T of sphere ratio, T of cylinder. So, T of cube, see, this is divided by 1, we can write like that. So, see, T of cube is equal to 0.65 is to sphere 1, here is sphere 1 also. So, 1 is to cylinder is 0.76. So, these are the ratio. These are the ratio. Clear? These are the ratio. So, which option? 0.76, 0.65, 0.65, 1, 0.76. 0.65, 1, 0.6. This is the correct answer. Clear? So, in the exam, be careful, okay? From this one, be careful. This is a very simple, but there is a chance of mistake for that this portion. So, be crystal clear. Find any two dimension, either A, R, S, D, in the form of one dimension. In the form of one dimension, then you have to use this one and find the ratio. Clear? Everyone plays. This is clear or not, beta? Clear ना? Clear? Now we'll shift the, मैं दूसरे प्रॉब्लम की तरफ बढ़ रहा हूं. Write down. Okay, right? Now I will read the question. The dimension of cylindrical riser, that riser, cylindrical riser, it is h by d is equal to 1, which is to be used to feed steel casting of 30 centimeter, 30 centimeter and 10 centimeter are to be determined. Okay, casting is poured horizontally. There is a casting is poured horizontally into the mold. Horizontally into the casting is poured into the horizontally into the mold. This is not, don't confuse. Casting is poured horizontally into the mold, and here cylinder is top, and casting will produce. That means this is your beta bottom gate system. So casting poured horizontally to the mold, या top gate system horizontally. Okay, using the modulus method, very important. Using the modulus method, the diameter of the riser in centimeter. Diameter of riser in centimeter. Okay, so we'll start. Start with the time's up. Now, so what is the modulus method? Very simple. Student confused here. Sir, how to solve the question modulus method? And they know, but still they forget to remember this modulus method. So I will give you some insight. What is that? According to modulus method of riser design. So modulus method for riser design, and this riser is top. So modulus method for riser design. Okay. So modulus of riser is equal to 1.2 into modulus of casting. This is very important. This is the relation according to modulus method. Modulus of riser is equal to 1.2 times of modulus of casting, and this is, remember, okay. And what is the modulus? We already know, volume by surface area. This is the modulus, volume by surface area. Okay. Given, what is that? Top riser, yes or not? And these are the cylindrical. and that cylindrical D is equal to H. Cylinder is D is equal to H. So let's suppose this is your casting, and this is your riser, top riser. Okay, this is your top riser. Now, now let's suppose this is height of the riser and this is diameter of the riser. Clear na? Now, here this is a top riser beta. So heat transfer at this surface, heat transfer at this surface which is contact with the casting, both the temperature are same, there is no any heat transfer. So this surface you cannot consider, you are not considering. That means bottom surface of the cylinder, bottom surface of the cylinder does not contribute any heat transfer. So how many area which is required to heat transfer? Top one, this one, and this curved surface. So top and the curved surface is the required space for the heat transfer. Bottom surface is not. Why? Because this casting, this are the same. So bottom surface, this, what is the temperature of this casting? The same temperature at this face. Why? Because there is a liquid here. See, this is casting metal and there is a metal. So at this surface both are the same temperature. So we can neglect this. Okay. Now, so first we have to calculate easily surface area which is required for heat transfer of the cylinder. What is that? Cylinder pi, curved surface, pi d into h, curved surface, and top one, and top one. So top one is only pi by 4 d square. This is the surface area. So and d is equal to h, yes or not? D is equal to h. So here it is a d square, here d square. So this is 5 by 4 pi d square. This is surface area. What is the volume? Pi by 4 d square h, and d is equal to h. So this is pi by 4 d cube. Okay. So what is the modulus of riser? Volume by surface area. Volume is equal to pi by 4 d square d cube. This is volume into surface area. Surface area 1 divided by 5 by 4 pi d square. So my dear, if you rearrange this one, this is your dy 5. You can remember this thing. Volume by surface area, if one surface is not heat transfer, modulus of riser. This is modulus of riser. dy 5. So modulus of riser you have, we can easily find what is the modulus of casting. So casting dimension it is given beta 20, 20, 30. So my dear, this is okay. So now modulus of casting, volume by surface area of casting. Volume is how much? 30 into 30 into 10. Surface area is 2 into 30 into 30 plus 30 into 10 plus 10 into 30. Clear na? A into B plus B into C plus C into A. So this is your casting. So So that means modulus of riser is equal to 1.2 of modulus of casting. Modulus of riser d by 5, 1.2, 30 into 30 into 10 divided by 2, 30 into 30, 30 into 10, 10 into 30. So here we can easily find D is equal to, if you find D is equal to, this is 18 centimeter. Diameter is 18 centimeter for that one. Modulus method, diameter is 18 centimeter. So in this exam, if there is nothing is given, we can use. But here the modulus method, so we apply the modulus method, then we have to find the answer. Why? Because beta this is NIT question, so there may be a range will vary. If you use the another method, there may be a range will vary. And here it is in centimeter, in integer. So if we little bit vary, the answer will wrong. So in NIT, if they are asking that which method, so you can apply so that you can get correct answer. It is not in point. Okay. So, if this is your MCQ, you can use any method. In the MCQ, it is not giving this clue, this technique. That means it is not giving which technique you have to find. In MCQ, you have to find the diameter of riser. So you can apply any method. But in NIT, if it is given, must be use this method. Otherwise, answer will be little bit vary. So your option is wrong. Your fill in the blank, the entry of the fill in the blank is wrong. Will wrong हो जाएगा. आपका entry जो होगा वो wrong हो जाएगा. This thing is clear? Clear? Okay. So these are the modulus method. Now next, yes, please read this question. Next one. Resistance welding is used to make lap joint with a current 15,000 ampere for 0.5 second. Joint is assumed to be cylindrical in shape of diameter 4 mm and 1.5 mm. The effective resistance of the joint is 100 micron. The density of the material it is given 7.8 gram per centimeter cube. The heat lost to the surrounding. If heat required to melt the material is this one, heat required, this is per kg. Okay, 1795 kilojoule per kg is, so heat loss in kilojoule. Okay, you have to find it. Okay, I will give again, you have a timer. मैं आपको timer दे रहा हूँ. So I will just start. Time up. Let's start beta. Okay. So what is that? See my dear, again, as we know that, so there is a power source and it's have energy I square R into T, and that will go to the welding with a transmission efficiency some part it is a loss, some part it is loss in this welding, remaining it is like that. So how much it will loss? So this is our supplying, loss minus supplying is heat utilized, yes or not? So given you have to form a joint is assumed to be a cylindrical shape. There is a joint is for form resistance welding, okay, and joint it is a cylindrical shape. So this is your cylindrical shape of joint, okay, and that height is your 1.5 mm, and this dia of the cylinder it is given 4 mm. No problem at all, okay. This resistance it is given 100 microns, so this is your 100 into 10 to the power minus 6 ohm. Density of the material it is given 7.6 gram per centimeter cube of the material it is given, and current you are supplying 15,000 ampere, and time required it is your 0.5 second. Unit melting energy it is given 1795 kilojoule. This is per kg basis, not per unit volume basis. So sometime it is per kg, sometime it is per volume. Accordingly, you have to balance the unit. Okay, this is given. Now, what is heat supply? So heat supply from power source, heat supply from power source, I square R into T, yes or not? I square R into 2 T. I is what beta? 15,000, and don't forget a square. Sometime student in the rhythm they forget a square. I know that in the class I will बहुत सारे केस ऐसा देखा, यहाँ पे लिखने समय स्क्वायर भूल जाएंगे, ध्यान रखिएगा. स्क्वायर into R. R it is your 100 into 10 to the power minus 6, 10 to the power minus 6 into time, duration. Time it is your how much? 0.5 second. So what is that value? Please calculate this value. It is 11250 joule. 11250 joule. This is your what? Heat supply from the power source. Now, what is the heat required to form this cylindrical joint? So, heat required to form the weld. Yeah, heat required to melt the material. Heat required to melt the material. This is your heat generation, you can also say that. This is your heat generation. Generation from power source. From power source. Okay. So heat required to form the weld nugget. So what is that? See, UM, and UM is unit is what? Kilojoule per kg. We want this is your joule. So we want in a joule, kilojoule या joule will multiply with 10 to the power 3 into, we remove the mass. So mass. How to remove the mass? Density. Density. Multiply with the density. And what is the density? Kg per mm cube. Now again mm cube is there. So multiply with mm cube. That means we have to remove this mm cube. So there is your volume. Multiply with the volume. Volume of nugget. And what is the volume of nugget? Mm cube. So this kg, this kg, this mm cube, this one. So this is kilojoule. Okay. Now here it is important value. So volume of the nugget is your, so unit melting energy is how much? 1795. So it is your 1795 into 10 to the power 3. Done. This is your joule. Density how much? 7.6 gram per centimeter cube. So this is also, this is your centimeter, na? This is given centimeter. No problem. Unit balance is there. Centimeter cube. So we have to take the volume in centimeter cube. In centimeter cube. So this density meter square. This is meter square. So this centimeter square 1 is cancelled. Kg cancel. Centimeter, kg, and this is a volume, centimeter cube. Centimeter cube. So this is your mm, centimeter cube, kg per centimeter, and joule per kg. Okay, so this is joule, meter cube here. This is your meter cube. Density na, mass by volume. Centimeter cube. So this centimeter cube cancel. This centimeter cube. So this is what? Kilojoule. So convert it in joule. Correct. Now, density is how much? Gram, kg, kilojoule per kg, no problem. Okay. Okay. And gram. So whether we will write 7.6 cross 10 to the power minus 3 kg per centimeter cube. Why? Because this kg cancel, this kg and this kg cancel. So 7.6 cross 10 to the power minus 3. 7.6 cross 10 to the power minus 3. Done. Kg per centimeter cube. Now centimeter, volume pi by 4 d. We have to put d, it is in centimeter. So d, it is your centimeter 4. Okay, no problem. Centimeter. So you can convert it is centimeter into meter also. So this is your, we'll write like that, no problem. 4 square into 1.5. Okay na? Pi by 4 d square. Now my dear, see. This unit is what? Joule per kg. Joule per kg, just balance. It is in joule now, not. Density is what? This is your kg per centimeter cube into volume. This is your mm cube. Now there is one missing then. So we have to convert this into your this was centimeter. You can take centimeter. So you can convert it is in centimeter. It is in. So convert it is in centimeter. So conversion into centimeter is what? 10 to the power minus 3 centimeter cube. Yes or not? So here we have to multiply into 10 to the power minus 3. Correct now? correct? So this is your mm, हाँ कोई बात नहीं. So if you multiply, if you solve this one, if you solve सेंटीमीटर क्यूब, mm को हमने सेंटीमीटर में बदल दिया. So 1 mm में 10 माइनस 10 to the power minus 1 सेंटीमीटर, यानी 10 सेंटीमीटर इज इक्वल टू 1 mm. So 1 mm 10 mm is 10 centimeter is equal to 1 mm. So 10 mm is equal to 1 centimeter. So 1 mm is equal to 1 by 10 centimeter. So 1 by 10 is equal to 1 by 3. So 10 to the minus 3 centimeter. Okay. So this is 10 to the minus 3 centimeter. This is a gram, kg, 1000. So if you resolve this one, this is 263.912 joule. Why? Because this is centimeter. So this centimeter cancel, this kg cancel. So this is joule. So this is your heat required, and this is heat supply. So heat supply, this one, heat required to form the weld, this one. So it is a heat supply. This is your heat required, and this is your heat loss. So heat loss is how much? Supply minus required is equal to loss. So heat loss, heat supply minus heat required. Heat supply is how much? 11250. Heat required is how much? 263.912. If you solve, this is your 10.986 kilojoule. This is your heat loss in kilojoule. That means in joule, it is your 0.01. It is a heat loss. Very minimum loss is there. Clear? This is clear, na? So please, I requesting you, in this section, there must be follow a rule of unit dimension. Please check all the parameter, will check the unit, otherwise answer is wrong. आंसर आपको रॉन्ग मिल जाएगा, क्योंकि ये मैक्सिमम चांस है कि रेजिस्टेंस वेल्डिंग का जो क्वेश्चंस है वो आपको एनईटी में मिलेगा. So there is a no chance to verify from the option. Clear? Now the next problem. Yes. This is our next problem. Yes, please read this question. Steel piping is to be provided by a centrifugal casting. So the process is centrifugal casting. The length, it is your 1 meter. The inner diameter is 1 meter. Length, it is your 4 meter. Inner diameter is 1 meter. And thickness, it is your 20 mm. The thickness, it is your 20 mm. Using basic equation of dynamics and static. उसको छोड़ दीजिए. The ratio of speed needed to have a centrifugal force. What is the rotational speed? N value in RPM. What is the value of this thing? So that the centrifugal force is your 8 times of weight. ये हो जाए 8 times of weight. Okay. So what is the speed of the casting, speed of the cylinder? This is centrifugal. 8 is what is given beta? G factor. So G factor is what? Centrifugal force the centripetal force divided by weight of the casting. Okay. Now, I will give you a 1.5 minute time, no problem. Okay. चलिए स्टार्ट कीजिए. Time's up. Okay. Done. चलिए देखिए तो what is the given? G factor. What is the G factor, beta? You know anyone? What is the G factor? Why this G factor is important? See, G factor in the centrifugal casting play the very important role. What is that, beta? In this G factor, this have a range approximately 60 to 120. This is your optimum G factor. So, if you less than 60, the G factor, if it is less than 60, what is the disadvantage? And if the G factor is greater than 120, what is the advantage? See, as we know that these are centrifugal casting. So, there is a material on the periphery. This is the axis of rotation, N. So, my dear, if the G factor is very less, if the G factor is very less, so that the material may be fall down from the surface, if the G factor is less. At the surface of the material, which is stick to the surface. Why? Because this is a rotation. So, due to the rotation, the molten metal will be spread out and it will be stick to the surface. Stick to the curved surface, inner surface of the curved surface, inner curved surface. Now, if the G factor is less, it may be the material will be drop out from the top portion. That is called raining. What is called raining. So, if the G factor is low, the material may be rain out. If the G factor is very high, approximately 110, the material may be splish out in this side. This side the material may be splashing. So, low raining, high splashing. So, we have to optimize this range always for the good centrifugal casting. And this, if you calculate this G factor, this is m omega square r divided by weight m into g, m will cancel. So omega square into r divided by g, it should be a optimum in between 60 to 120. In between 60 to 120. Okay? So it is given here, that means G factor is here, it is given centrifugal force, that means m omega square r is equal to 8 times 8 या 80 beta, not 8, 80 times weight, that means here it is given m omega square r is equal to 80 into g. Now the main part is to calculate r. R is varying beta. Inner radius, let's suppose this is our inner radius and this is our outer radius, the material which is there here, the material it is here. So it will create inner and outer radius. So here we have to find r. This r is your mean radius. R is your mean radius, and it is your half d outer plus d inner by 2. Yes or not? Yes or not? Why? Because this is a mean. So put half. Now here, how to the inner diameter it is given or not? The length, the inner diameter it is given 1 meter. That means di 1 meter. Okay. Now outer diameter is how much? It is not given, but thickness it is given. Thickness, this thickness it is given. This thickness it is given 20 mm. So outer diameter is how much? 1 plus 2 into thickness. Diameter, na? Not radius. So this is your 1 plus 2 into thickness is your 0.02. Yes, 0.02. So how much it is? 1.04 m meter. So that is your 1040 mm. So and this is your 1000 mm. Okay. Put this value back here. If you put the mean radius, it is your, if you find, that is your 510 mm, or you can say that 0.51 meter. 0.51 meter. Okay. 0.51 meter. Now put this value r back here. G value, find the omega. From this relation, omega square r is equal to 80 into g. So my dear, here omega square 80 cross 9.81 and r just now 0.515 0.51. So this is your approximately 1538.82353. This is your omega square. So if you find omega square root, so this is your 39.228 radian per second, and we know that omega is equal to 2 pi n upon 60, 39.228. From here we can easily find n. So n is equal to 60 in how much? 60 into 39.228 divided by 2 pi. If you solve this one, exactly it is equal to 374.6 rpm. Correct na? Correct, my dear? Correct? So this is the question related to the Z factor. Correct? Done? Any problem? If you have any problem, please you can reply in the comment box. It is मैं बहुत ही ज़्यादा खुश होऊंगा जब आप कुछ क्वेश्चन पूछेंगे, and I also very happy to reply your question. Okay, so this is done. Now next, yes, this is important question. This is again important. Please read this question. Determine the dimension of the pattern. Determine the dimension of the pattern of the casting as shown in figure. Figure it is given. The figure it is given. I will just draw the figure. This is your casting. It is given. Okay, this casting it is given, and there is also a hole, through hole. This is a hole. On this one there is a hole, and this dimension it is given 200 mm. This dimension it is given 100 mm. And this dimension it is given 150 mm. And this diameter of this diameter it is given 60 mm dia. This is given. So determine the dimension of the pattern. We want this one, and for that one we want the pattern for the casting as shown figure. This is casting. So for this casting we want the pattern, and the shrinkage allowance it is given 20 mm per meter. Machining allowance of all the surface and the bore is 1 mm. Machining allowance, all the surface and bore is 1 mm, 1 mm and 1 mm, and 0.75 and 1 degree, 0.75 and 1 degree draft allowance for external and internal dimension. Very important. Language is also important. So this is your draft allowance for external features, and this is 1 degree of draft allowance for internal feature. Okay, so this is your draft allowance. Draft allowance. This is your machining allowance, and this is your shrinkage allowance. Okay, shrinkage allowance. So what, after considering all the allowance, what is the final dimension of the pattern? What is the final dimension of the pattern? I will give you again a 1.5 minute, and please try to solve it, my dear. चलिए भेजिए 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 भेजिए, बता रहे हैं, बताइए बताइए। डन। सो इसमें क्या है बेटा, काफी स्टूडेंट को कंफ्यूजन होता है कि सर ड्राफ्ट अलाउंस को कैसे ले, ड्राफ्ट अलाउंस को कैसे ले। तो दिस इज द क्वेश्चन रिलेटेड टू ड्राफ्ट अलाउंस आल्सो, एंड वी हैव टू मेक द final product. This is very good question. So all allowance, how to consider the all allowance? Okay. Now see this thing. Okay. So this is, yes, this is our product casting. We have to make this casting like that. Okay. Made this casting like that. Okay. And here is the diameter. This dimension it is given 200 mm, 200 mm. This dimension it is given 100 mm, and this dimension it is given 150 mm. Okay, this dimension it is given, and diameter, this diameter it is given 60 mm. This diameter it is 60 mm. Clear? Now here it is given shrinkage allowance. Given, na? What is the shrinkage allowance? It is given this one, 20 mm per meter. 20 mm per meter. 20 mm per meter. That means one, convert it is on, that means you can write like that, 1000 for 1000 mm. For 1000 mm, how much you provide the allowance? 20 mm. Yes or not? So for 1 mm, how much? 0.02 mm. This is the factor, multiplying factor. This is your multiplying factor. This is your multiplying factor. So my dear, this is your length, let's suppose. This is your width, this is your height, and this is your dia. So shrinkage allowance, if the material is cool, it will be contract. It will be contract. So for the, to compensation, to provide the allowance against contraction, if the material is want to contract, so we always give the allowance of the outer part of the external surface. This is external surface, है ना? This external surface, after cooling, it will shrink. It will shrink. That means the dimension is reduced. So we want the actual, so we have to make this allowance, so we can add this one, shrink it. So we can add. So lengthwise, 200 plus 200 into multiplying factor 0.02. So how much it is? 200 plus point, I think 4. So that is your 204 mm. So in this length, we have to provide 204 mm. Width 100, plus 100 into 0.02. This will be your 100 plus 2, that is your 102 mm. This much allowance. For height, 150 plus 150 into 0.02. So this is your 150 plus 3. That is your 153. That is okay. That is okay, no problem at all. If you provide a shrinkage allowance on diameter, so this is your external, internal surface. Internal surface. Now, my dear, if it will shrink, please tell me, there is a casting. In this casting, and the casting there is a hole. So after shrinkage, this hole will increase or decrease? Please tell me. Please tell me, if the body will contract, this hole will increase. Contract, that means shrinkage. So this hole will increase or decrease? See, my dear, see this thing. This is a part and there is a hole. This is a hole. Now it will be shrink. That means it will be shrink. That means it will be shrink. So shrinkage, that means it will be reduced. The size will be reduced. So how the size will be reduced? It will be go this side. So it will be go this side. It will be go this side. We will do this side. So this side will reduce, but the hollow will increase. So internal surface will increase. During the shrinkage, internal surface will increase. So internal surface will increase during shrinkage. Okay, so D is how much? 60 minus, we put a negative allowance. So for hole, negative shrinkage allowance. Okay, minus 60 into 0.02. 0.02. How much it is? 60 into 0.02. 60 minus 1.2. That is your 58.8 mm. Now, this is the dimension after we considering only the shrinkage allowance. So, what is the when we have to consider the shrinkage allowance on the pattern? So, what is the final dimension then? So, this dimension it is, yes, okay, this dimension it is now this. Now after considering the shrinkage allowance, this dimension is 204. This dimension it is your 102. This dimension it is your 153. And the whole it is your reduced. So this dimension it is your 58.8 mm dia. So after the shrinkage allowance, this is our my final pattern. Now, we will take the machining allowance. So machining allowance is how much? 1 mm. And machining allowance will provide each side. So lengthwise L. So this, that means one provide this side, one provide this side. So 204 plus 1 plus 1. This is 206 mm. Width. One down, one up. 102 plus 1 plus 1. 104 mm. Height. 153 plus 1 plus 1. This is 150 mm. Now, what is in diameter? What is the diameter? Please tell me. So, diameter internal. So, in the diameter we have to remove the material. We have to remove the material. So, in the diameter we have to produce the negative. Always this is external surface, internal negative. Why we are providing the negative? Why we are providing the negative? Why? Because we want the more material, so that machining, after machining, we want the hole have a more material. Why? Why? Because we have to provide the machining, and during the machining the hole will increase. If you do the machining, the hole will increase. So, for the increased diameter, actual size will increase. So, the allowance will give the negative. So, this is your 58.8 minus 2 into 1. Why 2 into 1? 1 plus 1. So, this is how much? 56.8 mm. So, these are the final when there is a machining allowance. When this is the machining allowance. Now, if this were machining allowance, now we give the tapered allowance. Yes. Now we provide the draft allowance. So, we will provide the draft allowance, and draft always provided on the vertical surface. This is draft, na? Draft is what? This is draft to easy removal. So, this is draft beta, this is casting. This is draft, this angle theta, this is draft. So, draft will provide this one, both sides. This is actual, we have to provide the draft. So, tan theta is what? Let us suppose we have to provide x, this one. So, tan theta is what? This height, let us suppose h. So, tan theta x by h. So, what is the x? H tan theta. This is the draft. X is equal to h tan theta is what? Draft. And theta value it is given 0.57 for internal, external, and 1 degree for internal. Clear? Okay. So, this is our my shape. Draft allowance. Okay. This is our draft allowance. Let's suppose. This is our draft allowance. Okay. Tapered. Tapering is a draft allowance. And the hole, this is tapered this side, so we increase this hole. So, this is a smaller hole. We provide the bigger hole like that. 1 second. This is the hole, small hole we have to create. This is tapered. Draft. If the hole is done, so we have to provide this draft allowance like that. So, here this is the angle theta. See, this is the angle theta. Okay, and this will this. So, this is the angle like that. This is the angle theta. This side, also this side, same. And also this is your slant downward. So, here it is also theta. Now, my dear, this is theta, same theta. Okay. So, after machining allowance, this is your draft. So this is your machining. This is how much? This is draft. So this is your actual size, 206. 206. This is your height, same. This is your height, 155. This is your draft, na? If you plot this one, this is your draft. So this is your actual 204 draft. Okay. Now, in the case of draft allowance, only consider vertical dimension, since draft allowance is not affected to the horizontal dimension. Very important. You have to write like a note. Note. In case of draft allowance, only considered vertical dimension. That means 155 mm. Vertical dimension, since draft allowance is not affected the horizontal dimension. Not affected of horizontal dimension. So, for external, tan theta is equal to, let's suppose this is x by 155. This is your draft. Okay. So here x is equal to 155, 10, and this is your external, and for external how much the draft it is? For external how much the draft it is? 0.75 degree. 10.75. How much it is? So this is your 2.02, approximately 2 mm. So we have to provide the draft 2 mm both side. 2 mm this side, 2 mm this side. So this total dimension, this one, for external one, this is your 206 plus 2 this side plus 2 this side. So this is 210 mm, 110 mm upper. 110 mm upper. Okay. Now for internal, very important. For internal. Now my dear, internal same, tan theta is equal to draft x by vertical height 155. So x 155, 10, 1 degree. If you calculate, this is your 2.7 mm. Now my dear, see one thing, internal feature is there. So tapering, here tapering it is this side. So see, here it will be downward. It will be downward. And if you take here line, very important, if you draw a line here, so but if you provide the draft on the external surface, it will be downward. If you provide the draft allowance on the internal surface, it will be up, downside it will be up. Here it is a downside, it will down. Here it is a downside, the draft is down, external. Here it is a inner surface, the draft downward is up. So we have to negative. to the negative for the compensation. Okay. So for the diameter, external surface D, this is your diameter is how much? After giving this one, 56.58. 56.58. This is your 56.58. After giving this is your 56.58. Okay, na? 56.58. Why? Because we are providing the draft this side 56.58. So D is equal to 56.58 this minus 2 into 2.7. So this is your 56.58 minus 5.4, that is your 51.4 mm. So this draft will have to provide this one 51.4 mm. So my dear, take one note. The draft allowance for interior surface is reverse the external surface. Yes or not? Just write down a note, very important note. This is your note. Note. This is your note, my dear. Okay, once again. There is a one note. What is the note? One note we have to write live. Note is what? The draft for the internal surface, draft allowance for the internal surface, draft allowance for the internal surface is reverse. Is reverse the external surface. The external is reverse the external surface. Draft allowance is the reverse of external surface. It is clear now? So this is very important things. So I want to discuss these things. For that one, all the allowance clear हो गया आपके पास. All the allowance. How, मतलब कैसे हम draft allowance को दो, कैसे machining allowance and कैसे shrinkage allowance. So all the things is all the parameter it is clear. Okay. So that's why this problem is important. Okay, now. So these are my final. After giving draft allowance, after giving machining allowance, after giving the shrinkage allowance. Clear? Clear, beta? Okay? Done. Now, next problem. Yes. Read this question. The component is made up of steel sheet. Sorry, if component is made of sheet which is 1.5 mm thick and it has a shear strength of 295 megapascal, then the punching load required. Punching load required for the component as shown in figure. The component दिया हुआ है, इसमें कितना punching force required होंगे? What is the punching force required? Okay, done beta? So again I will give you 1 minute. चलिए स्टार्ट कीजिए. Simple problem beta. Okay. So we know that, see, in punching, which type of force is required? Shear force. Punching will always done with the help of shearing effect. So there must be a shear force. So blanking force or punching force blanking or punching force F is what beta? Stress, shear stress into shear area. That's it. Force stress is equal to shear stress into shear area. This is what beta? This is what? Shear strength that means this is a fracture. This is a fracture. Shear area okay, this is shear area. Now my dear, so we have to find the force. So area, what is the area here? This area, all the area, this area we want to punch. So this area, this area, this area, this area, this area, this is a parameter into thickness. This is like that, na? This is 3 dimension beta. See, okay, it is like that. It is like that. So we have to find this area, not this area, my dear. We have to find this shear area. So where is the shear area? This is the shear area. So this is shear area. Okay, this is shear area. This one is your shear area. This one. So this total perimeter into this thickness. Yes or not? So here, very simple problem. Very simple problem. Okay. Now that is done. Okay na? Now we will discuss the next problem. See this thing, this problem, please see. The higher limit of, this is given, this is for the shaft, a smaller letter for the shaft. A smaller letter for the shaft, which is a small alphabet. A smaller alphabet is your for shaft. The higher limit of 20F8 shaft with a following data is, what is the higher limit? It is given I 0.05, this is empirical relation beta. It is given sometime, it is not given always. It is sometime it is given and sometime it is not given. So please remember this thing. Upper deviation of the shaft, it is given 20 mm fall in the diameter step. There is a 20, this 20, and diameter steps of itna. So we have to calculate this steps diameter. and step diameter is always beta mean of these two value, mean of these two value. Okay, so this is shaft. So these are, what is the notation? 20 F8, 20 F8, and this is small letter alphabet, this is shaft. So this is basic size 20, and shaft will start from notation here, from this bottom left to top right. Hole will start top right to bottom left. So A, B, C, D, E, F, G, H. If H will H either hole or H either shaft. It will be at this line, but this is F. So F, it is below line. So this is your F. Okay, na? So this is your shaft. Okay, and this is your fundamental deviation, E. Okay, and this is your maximum material limit, and this is your minimum material limit. So this is your higher limit, this one, higher limit, and this one is the lower limit. Why? Because this side decrease, this side is decrease. Okay, now, so first we have to calculate the D, which is mean dia of geometric mean of D1 into D2. So D1 is what? 18 into 30. This is how much? 23.2379 mm. Clear na? This is your D. This is your D. Now fundamental deviation, it is given. This is minus. Why? Because below. Minus 5.5 D pe power 0.41. 5.5 D pe power 41. Now my dear, minus 5.5 D, it is given 23.2379 pe power 0.41. And my dear, this answer is always in micron. So if you calculate this one, minus 19.975 micron. So if you convert it is meter, it is a minus 0.019975 meter. This is done. Why negative? Why? Because it is below side. Now, my dear, then what is the higher limit? Higher limit is what? This basic size 20, this basic size 20 plus this height, yes or not? 20, this is the basic side, there is a minus, so plus into minus of this one, so minus, this is the minus, always take minus, minus of 0.019975. How much it is? 19.98, approximately 19.98 mm. This is your higher limit. What is the lower limit? So for the lower limit, for the finding the lower limit, we should have find this tolerance zone. This is your tolerance zone. Tolerance zone. And it have a notation. This is your 8. So this is your 8 na. So it's have value IT8. This is called IT8. IT8, and IT8 value is given 16I. So if you calculate this tolerance zone, that means IT8 is equal to how much? 8I, much 16I. These are 16I. Now my dear, I is where you have to calculate this I value. This I is calculated from this relation. So I is equal to, this I is equal to 0.45 d pe power 1 by 3 plus 0.01 of d. Now my dear, d value you have 0.45, d value 23.2379, 23.2379 pe power 1 by 3 plus 0.01, 23.2379. If you calculate this value always in microns, so it will we convert into mm. Calculate this one. Let's suppose this is x value, any x you have. Now, so here 16 into x, that is your mm. So this zone, this is a 20, this is your shaft. So this ipsila you have, this you have 16I, and this is your upper limit, and this is your lower limit. So upper limit yani higher limit, this one, and lower limit is what? 20 minus of this one, 20 minus of E plus 16I. Calculate this is your lower limit of the shaft. So upper limit and lower limit, how to calculate? These are the concept. Clear? These are the concept. Now, so that is done. These are the simple funda. Now take the next problem. Take the next problem. Hole of diameter 20 plus 0.06 plus 0.05. Lower limit and upper limit it is given. Lower limit is 0.05, upper limit. Both are in the unilateral, not bilateral. Unilateral system is there. Are to be electroplated. These holes are electroplated. If the desired diameter of the hole after plating is this one, then the plating thickness. So plate thickness is varies between, which is the option? Plate thickness varies between. So again I will provide you 1 minute. Start. Done. Time's up. Now, so these are the electroplating concept. So take one thing, note. What is that? This is hole generally. If you provide the electroplating on hole and shaft, so what is that? How to calculation? This will. So let's suppose this is your shaft. First, let's suppose this is your shaft. Okay. This is shaft, and we are provide the plating, electroplating on the shaft. Electroplating on the shaft. Yeah. This is your outer dia. Okay. This is your outer dia. So this is shaft plating. So if you find the this is let's suppose final dia. So if you find a final dia, that is your internal dia plus 2 into thickness. This is for the shaft plating. Now, if there is a hole plating, so hole we provide the plate inside. Let's suppose this is a hole. This is your hole. So if you provide this is your plating. So this is your internal dia, and this is your external dia DF. So in this one, this is hole plating, hole plating. So in this case, DF is what? Di minus 2T, Di minus 2T, and T is what? T is what, beta? Plate thickness. T is what? Plate thickness. So you can find, so this is our case, hole. This is our case, beta. So before plating it is given, after plating it is given. So before plating that means final, this outer before plating. So before plating F, after plating I. So before plating HF is how much? 20 plus 0.06 plus 0.05. After plating 20 plus 0.03 plus 0.01. It is given for hole. It is given for hole. Now, my dear, so what is the upper limit of the hole? What is the upper limit of the hole? So if you find this your basic size 20, so this is I think hole this side. So this is your upper limit 0.06. This is your lower limit 0.05. This is your before plating. Now, this is your before. Now, after same 20, after plating it is like that. This is 0.03. This is 0.01. Correct, na? Correct? Correct? Now, so upper limit of this initial, let's suppose this one. For this one, what is upper limit? Upper limit of di. Upper limit of di is your di. df plus 20 di. So upper limit of di, upper limit of df. Okay. So 1 second beta. di it is given upper limit 20 di before, and this is your after. This is your after. So after upper limit. So this is your after. This is your after. This is your after. And this is your before. है कि नहीं? So after में upper limit कितना होगा बेटा? After में upper limit so di is what? df plus 2t. df is how much? Upper limit df plus 2t. 2t, thickness of the plate. They are asking thickness of the plate. Okay. So this is your upper limit, lower limit. So upper limit of di is your 20.03. Upper limit of lower limit of di 20.01, correct? Upper limit of df 20.06. Upper limit of lower limit of df 20.05. Now this is done. Now the relation. So we know that lower limit of df is equal to lower limit of di minus 2t. Yes, see, df is equal to di minus 2t. df is equal to di minus 2t. So lower limit of df it is given. Lower limit of df it is given. Lower limit of df. Lower limit of df. Okay, no problem. Lower limit of di. So lower limit of df it is final और ये इनिशियल. फाइनल इज ज्यादा. हाँ, लोअर लिमिट ऑफ df is 20.05. lower limit of di is 20.01 minus 2 into t. So this is how much? If you write this thickness, it is magnitude में ले लेना. This thickness is it is if you correct 2.05 minus. So this is your 0.02 mm. That means 20 microns. This is your lower limit of thickness. This is lower limit of thickness. Now, upper limit. Now, upper limit of thickness. Upper limit of thickness. So, upper limit of df, upper limit of df is equal to upper limit of di minus 2t. Yes or no? So, upper limit of df is how much? 20.06. Upper limit of di is how much? 20.03 minus 2t. So, this t is equal to 15 microns. So, my dear, t will vary from 15 to 20. T will vary from 15 to 20. Yes, B option. Thank you. So, this problem is done. That means, if you calculate the whole, अगर आप calculate करना चाहते हो whole का plating and or shaft plating, so this is the method to first calculate the. That means, see, if you provide the plating, this is inside. If you provide the plating of shaft, this is outside. So, these are the things simply. So, just recall this thing, okay. Now, my dear, okay, yes, just start this problem. This is also a very good problem. Just start with a. So, what is that? See, a single pass rolling operation of thickness. So, a single pass rolling operation is there. The thickness of 100 mm wide plate. So, 100 mm wide plate is reduced to 20 to 15 mm. The roller radius, it is given 125 mm roller radius. Rotational speed of the roller, it is given 8 rpm. The average flow stress, it is given. That means mean flow stress. Mean flow stress, it is given. The power required of rolling operation. The power required in rolling operation in kilowatt. Okay. I'll give you some background. What is given here, beta? What is given? Given it is width of the plate, it is given 100 mm. Initial thickness, it is given 20 mm. After rolling, final thickness, it is given 15 mm. Radius of the roller, it is given 125 mm. N is the RPM, it is given 8 RPM. Mean flow stress, it is given with a 400 megapascal. We have to require rolling power P in kilowatt. Done na? So, for calculating the power, beta, for calculating the power, we know that power. See, these are the certain rhythms, common question of the rolling. What is power? Torque into omega. Torque into omega. Okay. What is torque? Torque, force exerted into arm length. If nothing is given, you can put the arm length. You can put the arm length with a 0.5 into projected length. 0.5 into projected length. How to find the projected length? Projected length, it is equal to square root of R into delta T. Delta H. Draft. Delta H is your draft. This is your projected length, LP. So, projected length LP you have. Now, how to calculate force? Force you have to calculate stress by area. So, mean flow stress into projected area. mean flow stress given. How to calculate projected area? This projected area is your length projected into width. This is the pattern. Remember this thing. Remember this thing, beta. What is that? First we want that power, torque into omega. If you don't know this thing, you cannot solve. These are the empirical. Torque is equal to force into arm length. The arm length is equal to 0.5 into projected length. Projected length is equal to root under r radius of floor into draft. Projected length calculated. Now, then we have to calculate the force required. Force is a mean flow straight into projected area. Projected area is what? Length into breadth. That is clear. Now the problem is, so this is power required for one roller. Very important. Note, this power for one roller. Very important. For one roller. And in single pass, it is nothing is given. So let's suppose there is a pair of roller. So power required during operation, during this operation, during this is a 2 into P. Why? Because 2 roller in one pair. Clear now? 2 roller in one pair. So that is your total power required. Now we have to put all this value. We know this thing. Okay. So what is that? Length, projected length, that is equal to root under r into delta h. If you calculate, this value is equal to 25 mm. Projected area, length into width, that is equal to 2500 mm square. Force, average mean flow stress into projected area, that is equal to 10 cross 10 to the power 5 Newton. Arm length, this is equal to 0.5 into projected, that is what 12.5 mm. Omega 2 pi n upon 60, that is your 60 pi by 16, 60. So from here we can calculate the torque F into arm length. From this one we have to calculate power 2 into torque into omega. So this is your 20 pi by 3 kilowatt. 3. So these are the things. Okay, my dear. Now, so up to that I will stop here. Now tomorrow we will discuss some problem related to the electrochemical machining, that means non-traditional, single point cutting tool, multi-point cutting tool, and also SIM. Okay. So before ending this session, again I have one announcement for you. If you willing to join the live online program, that is my program features 800 plus hours of live classes with live interaction, more than 800 plus. Also आपको ये भी मिलेगा theory book, exercise book. In theory book there is a level 1, level 2, level 3. Level 1 related to the normal exam, PSUs, SSC, JEN, ISRO, like that. Level 2, ES level, ES objective level, problem level 1. Level 2, gate level, and level 3, it is more than gate level. And in this one there is a 4000 plus book is there, question is there. Now along with that 33 33 of get question bank with a video solution. Okay, 12 personalized one-to-one mentorship is there. 12 one-to-one mentorship in a year, and also 130 plus online test with a video solution and mock test and many more. That means आप अगर ऑनलाइन टेस्ट देते हैं तो आपको सिर्फ और सिर्फ सॉल्यूशन ही प्रोवाइड नहीं किया जाएगा, उसके साथ साथ उसका वीडियो सॉल्यूशन भी प्रोवाइड किया जाएगा ताकि आप उस क्वेश्चन को देख के समझ सके. फॉर बुक फॉर मोर डिटेल्स you can call on this number, they can directly help you. Okay, now there is another thing, there is a Telegram. So in the Telegram group, these are free of cost and you can join immediately. Why? Because there is a मतलब बहुत सारे चीज informative, these are very important information. Okay, so what is that schedule, कब schedule lecture होंगे, YouTube का क्या होगा, ये सब update उस पर रहेगा. Today's lecture, what is the today's lecture? The PDF will be uploaded on this Telegram group. Important update regarding the seminar and webinar, and all the government job related to the engineering and PSU's job notification all उस पर reflect होंगे. Expert session for important topic. Let's suppose there is an important topic is there and we want to I want to take the lecture, so that update will be on the Telegram group. In the Telegram group daily there is a quiz, each and every department, and that quiz is very important, regular updation. So if you join, you can visit this link and you can join this Telegram group. Okay beta, up to that, thank you, bye bye. Tomorrow we will meet again 5 to 8 for the better question. I will bring you the better question related to the non-traditional machining, single point cutting tool, multiple point cutting tool, and SIM. Clear? Thank you. Bye bye.